By the end of this lesson, you should be able to find the third side of a right triangle given two sides by using the Pythagorean theorem, the famous Pythagorean theorem. So, in a right triangle, the sum of the squares of the lengths of the legs. So the legs of a triangle are I always call it the L part. So if you look at our example, those are our legs, the L part. It's like kind of a backwards L. So those are my legs. And then the hypotenuse. So leg, hypotenuse. Your hypotenuse is opposite your 90-degree angle. Remember, all right triangles have a right angle in them. All right? So if you add the squares of the lengths, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. And we famously hear a squared plus b squared equals c squared. And we call a and b, we always label as the legs. If you ever get some whole numbers that satisfy that, we call that a Pythagorean triple. So for instance, 3, 4, 5. So if my legs were 3 and 4. So a famous one is the 3, 4, 5 triangle, because that would be a 3, a 4, and a 5, because they work. 3 squared plus 4 squared equals 5 squared. Okay, 3 squared plus 4 is 6. 3 squared is 9. 4 squared is 16. 5 squared is 25. We get 25 equals 25. That's a famous one. As you do this lesson, you'll come across a couple more that work. So whenever you get whole numbers that work, we call that a Pythagorean triple. Okay, so 3, 4, 5 is definitely not the only one, but that's one that works. We're going to use the Pythagorean theorem to find missing side of right triangles. You'll have one method when you're trying to find the hypotenuse and a slightly different method when we're finding a leg. So one of the things I like to do first is to figure out which one of my sides is the hypotenuse. It's always the one opposite the right angle. So in our case, x is the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. All right, so let's do those exponents first. We get 9 plus 9 is x squared, and 9 plus 9 is 18. So we know the hypotenuse squared is 18. To find what the hypotenuse is, we do the inverse of squaring, which is the square root. Just like addition and subtraction and multiplication, division are inverses. If I want to find what x is, I'm going to do the square root of 18. So you put that into a calculator. Remember, the Decimus calculator is quite helpful if you want to use that. And we're going to round 2 decimal places. So I guess we should use the approximate symbol. Our hypotenuse is about 4.24. So when I type in the square root of 18 in the calculator, I get about 4.24. If I look at example 2, the opposite of the right angle is 15. So 15 is the hypotenuse. And I get 9 squared plus x squared. All right, so I'm going to square everything. 9 squared is 81. 15 squared is 225. 15 times 15 is 225. And I need to get my variable by itself, so I'm going to subtract the 81. And 225 minus 81 is 144. Again, now I have x squared equals a number. To find out what x is, I do the square root. And in this case, I get a whole number, which is 12. So that missing side is 12, and we have a Pythagorean triple, 9, 12, 15. So again, notice when I find the hypotenuse, I square my two legs and add them together and find the square root. If I'm finding a leg, I square the leg I know, the hypotenuse I know, and then I subtract to the other side and then do the square root. So example number 3, let's see. 65 is my hypotenuse, so leg squared plus leg squared equals hypotenuse squared. 65 squared is 4,225. 25 squared is 625. I'm going to subtract 625 from both sides. All right. I get x squared equals 3,600. And again, if I want to get x, I do the square root of that, which is, oh, a whole number. We got a Pythagorean triple. Pythagorean triple, which is 60. So in this case, x is 60. Again, if I'm finding the hypotenuse, I would just square the two legs, add them together, find the square root. Whenever you find a leg, you're going to end up doing some subtraction. I want to do one more example, and it's kind of further down the sheet. If you look at the first number 5, it's a little bit different, so I want to kind of talk about that. Okay, we have a triangle here. It's isosceles because 9 and 9 are the same, so we know it's an isosceles triangle. If we draw a line from that vertex down, it's going to end up splitting that opposite side in half. So I know that this is going to be 4 and this is going to be 4. So if I want to find x, now I have this right triangle here where the hypotenuse is 9. The leg I don't know, and the leg I do know. So I'm going to do x squared plus 16 equals 81. I squared those. Subtract 16. And I get 65. And then I'm going to do square root of 65. Whoa! And the square root of 65 is, boom, 8 is about. So I guess we should use that about symbol. About 8.06, 6/100. Again, you can do the square roots on the calculator, of the decimal calculator. Your phone should probably have it. Sometimes if you have you have to turn your phone on the side and that will pop up. Okay, so the Pythagorean theorem can be used to find the missing sides of a right triangle. So what I would like you to do is now finish the examples on this page. So that would be 1 through 6 minus the 5 we just did, and then 1 through 6 again.